Alright, welcome back guys. I actually debated on whether to make this video for support because all of this material we've seen before, but I decided I wanted to because it'll give you sort of a review on some of this stuff, and some of these are slightly nuanced. You may not have seen some of these problems exactly as they appear here. So the first part of this is just multiplying two binomials. Okay, so we've done this previously, but I wanted us to look at a couple other examples. So this, they're called binomials because they have just two terms. It's a polynomial with just exactly two terms. And so you can see here we've got this binomial in parentheses and it's squared. So we know that when it's squared, that means we're multiplying two of them. Okay, or in other words, you're multiplying that binomial by itself. And so to actually do this, you can utilize, I mentioned this previously, the FOIL method. Or basically, you can think of it like you're going to distribute the first term of the first binomial to both terms in the second binomial, and then you'll distribute the second term here to both terms in that second binomial. Okay, so we have a times a. If you remember, we add those exponents, so we get a to the second, and then a times negative 2b will just be negative 2ab, and then we'll distribute the negative 2b to this a, and that's going to give us another negative 2ab. Remember, the order doesn't matter because this is understood multiplication right here. And then furthermore, negative 2b times another negative 2b is going to give us a positive 4b to the second. And so now that we've done the multiplication, this is where we go and we look for like terms. And lots of times, guys, it's these two in the middle. These are like terms. They both have one factor of a and one factor of b. So if we combine them, negative 2 minus 2 is actually negative 4. We get negative 4ab, and then finally plus b squared. So we end up getting a trinomial for our result. And then example 2 is very similar. We have another binomial here, and it's squared. So we'll write it out twice. And multiply again. Okay, so y to the fifth times y to the fifth. Remember, add those exponents, so you're going to get y to the 10th. And then, y to the fifth times 3 will be 3y to the fifth. Then we'll distribute the 3, and that's going to give us another 3y to the fifth. And finally, 3 times 3 is 9. And again, just like the last one, these two terms in the middle are like. So 3y to the fifth plus 3y to the fifth will be 6y to the fifth. And you just bring down your other terms. Okay, so we get another trinomial here. All right, now the rest of this is just some extra practice with what we looked at in, I believe, section 7.4, solving quadratic equations. Okay, so remember, this is the standard form for quadratic equation, but what makes it quadratic is that there has to be an x squared term, because some quadratic equations, guys, they may not have the x term, or they may not have the constant term, but they will definitely have the x squared term. And depending on, whether they have all three terms or not, that can determine the method that we use to actually solve the quadratic equation. And we looked at some of these methods previously. So factoring, the square root method, and then the quadratic formula. The only method that will work for any quadratic equation, regardless of the number of terms that it has, is the quadratic formula. But as you guys know, this is the one, we probably want to try to stay away from if we can, especially if we're doing it manually, because there's a lot of room for error there. All right, now one thing we haven't talked much about in this class is there's a way to factor, and it's called factoring out a greatest common factor. And so here's an example. Factoring is really the opposite of multiplying. So when you multiply two things together, you get a product. Well, if you take that product apart, what you have are the factors. So for example, if I multiply 5 times 3, I get 15. The 5 and the 3, those are called the factors. Okay, and then the 15 is called the product. So lots of times we may be starting with the product and we want to factor it. So in other words, we want to write it as 5 times 3 or something times something else. Okay, so that's what factoring is. All right, now look at this example right here. So we've got 5x times this trinomial that's in parentheses. So the way you multiply, if you remember, is you distribute this 5x. So you multiply all three of these terms by 5x. And if you do that, you get this new trinomial. Okay. Well, factoring, guys, taking out what's called the greatest common factor, and sometimes you'll see it referred to as an acronym, just the GCF. Factoring out a greatest common factor is basically just undoing that distribution. So over here, if you look, all three terms, they've all got a factor of 5 in them because the 5 got multiplied to all three of those terms. So you can actually take it out. And furthermore, they all have at least one x, one factor of x. And so you can take out that factor of x. So you can see here, each of these terms has a factor of 5x. So you take it out, and what you have left is really what you started with over here. Okay? This is called factoring out the greatest common factor. And let me show you. The way I show my other classes, in which we do a lot of factoring, is you look at these three terms and you ask yourself, what do they all have in common? Well, they all have at least one x. Okay, so that's part of my greatest common factor. And then furthermore, you look at your coefficients, the 5, the negative 15, and the 5, and you could say, well, what number would go into or divide into all three of those? Well, 5 will. And so you take out a 5 and an x, or 5x. And the way I show my students how to determine what's left, so the 5x got put in here from multiplying, from the distribution. So to take it out, you do the opposite, which is division. So you can go back and divide all of these by 5x, and that'll tell you what you have left. So this first term, the 5s would divide out, x to the third power divided by x to the first power. When you're dividing, you actually subtract exponents. So you would get x to the second. And then in the next term, negative 15 divided by 5 is negative 3. And x to the second divided by x to the first, if you subtract those exponents again, you're going to get x to the first. And in the last term, 5x divided by 5x is actually just 1. Okay? Because remember, anything divided by itself is 1. And if you look, this is what we started with over here before we actually distributed the 5x. So this is called factoring out a greatest common factor. Okay, 5x was a common factor to all three of those terms, as you can see. The reason this is important is because on this example 3, sometimes these quadratic equations, they may be missing a term. So this is missing the constant term. So you've got the x squared term and the x term. So we can solve this one by factoring. But it's not a trinomial, it's just a binomial. So the only way we can factor it is by taking out a greatest common factor. So you look at these two terms and you ask yourself, well, what do they have in common? Well, they each have at least one factor of x, okay? And so what you do, I'm going to put this in the notes, greatest common factor here is going to be x. So you take out that x, and you go to see what you're going to have left, you go back and divide these by x. And that's what you put in your parentheses. So right here, x to the second divided by x to the first, subtract those exponents, you're going to get x to the first, or just x. And then over here, your second term, your x's are going to divide out, and you're just going to have that minus 3 left over. And then make sure you bring down the equals to 0 part. So now we have it factored. Okay, so I'm going to put in the notes that we solved this. We're going to solve this one by factoring. We factored out the greatest common factor. And if you remember from the factoring method, guys, what we have to do to actually solve this is we take each of these factors and we set them equal to 0. So one of my factors is just x. When I set it equal to 0, it's already solved. So this tells me that x is 0, so 0 is one of the solutions. But for my other one, it's a binomial factor. When I set it equal to 0, to solve it for x, I'm going to have to add 3 to both sides. And so if I do that, that's going to give me x is equal to 3. So 3 would be the other solution. So my solutions are going to be 0 and 3. Okay. These quadratic equations, guys, there's lots of ways to solve them. You could have used the quadratic formula if you want. Your a would be 1. Your b would be negative 3. And since you don't have a c, you would use 0 for it. Plug those numbers into the quadratic formula and evaluate it. And if you do everything correctly, you should get 0 and 3. All right, now example 4. This one is a quadratic equation as well because it's got a b squared term. It doesn't have to have the other terms, but as long as it's got the squared term, it's quadratic. And if you remember from last class, if it's missing the middle term, so if it's missing this term right here, okay, so in this example, we've got the squared term and we've got the number. Okay, so we've got the first term and we've got the constant, but we don't have the middle term. So when we're missing the middle term, we can use the square root method. And what you do, the square root method allows you to solve this quadratic equation for b directly. What you do is you get the term with b by itself. Well, in this case, it's already by itself. It's just on the left-hand side. And then what you do is you want to get rid of the exponent 2 right here. So the b is being squared, so the opposite of taking the square root, the opposite of squaring b is going to be taking the square root of b. So if you remember from the previous class, we're going to take the square root of both sides. And anytime you're solving an equation and you have to take the square root of both sides, you have to put a plus and minus, because you get 2 roots. And so the square root of b squared is just b. Bring down your plus and minus, and the square root of 9 is just 3. So our solutions are b is equal to negative 3 and positive 3. Now in your homework there is I believe that there is a plus minus key, so if you want to use that, you could type in plus minus 3, or you can type it in as 2 distinct numbers separated by a comma. Negative 3, comma, then positive 3. This one could have been solved using the quadratic formula as well, but you would have had to move this 9 to the other side and then determine what your A, B, and C are. And then example 5, the last one, we're going to do this one by factoring. I say factoring, guys, because I can sort of look at it and I can tell that it's factorable. That just comes from a lot of experience. Alright, now there is something different about this one. The first thing I'm going to do is put this in descending order. So I want my squared term to come first. And then I want my D term to come second, and then you always want your constant to be at the end. Okay, so it's in standard form right now. But what's different about this one is that this first term has a negative sign in front of it. And whenever you see that, unless you're going to use the quadratic formula, if you're trying to factor, the first thing you want to do is factor out a negative, or factor out a -1. In other words, we're looking at this like our greatest common factor is -1. So if I take it out, I'll open a set of parentheses, and to see what's left, you go back and divide these by -1. Well, guys, just like multiplying everything by -1, if you divide everything by -1, that's just going to change the sign. So this will become positive d squared, this will become negative 3d, and that will become negative 40. Okay? And so now what we have left in parentheses, we can factor. And so if you remember, we open two sets of parentheses. We know we need a d times a d to give us back the d squared. And then we need to find factors of negative 40 that when combined will give us negative 3. So this is where we can make a little factor chart. I think negative 8 and positive 5 will do it. If you combine those two, negative 8 plus 5 is negative 3. And when you multiply these two numbers, they still give you negative 40. So we'll plug them in. D minus 8 and D plus 5. And don't forget that -1. Okay? So we have it factored now. Now what we need to do is to solve it, we're going to set these factors equal to 0. But you only set the factors that have variables in them. So this first factor, the -1, or the greatest common factor, we don't set it equal to 0 because it doesn't have a variable with it. But we do set our two binomial factors equal to 0. Okay, and then we solve each of these for d. So if we do that, we're going to get d is equal to 8. And then over here we'll subtract 5. So we'll get d is equal to -5. So those would be our two solutions. We could say d is equal to -5, comma, positive 8. And we did this one by factoring. Although you could have, once you had it in descending order, you could have used the quadratic formula. A would be the -1, it's understood here. B would be the 3, and C would be the 40. Alright guys, well that's just some extra practice, so hopefully it helped, and I'll talk to you next time.